maths. We shall be considering volumes of cylinders. This topic is specifically for those of you who are in Form 3 or Form 2. Form 2 because that is your main topic, and for those in Form 3, this is going to be a topic that of course you need to revisit. Now, before we start this topic, you should recall that back in Form 1, you learned about areas of circles. A circle, of course, you learned that is a plane figure that has a central point, and certain dots can be traced or that are equidistant to that central point known as the center. Now, why is circles very important in this discussion? If you observe the figure on your screen, that is a cylinder. A cylinder, as you see on the screen, has circular cross-sections or bases. And that is going to help us, especially in deriving the volume of a cylinder. Now, consider the figure on your screen. You observe that this is a circle, and that the area of a circle is simply pi r squared, if you can recall, in the first year. And again, if you observe from this point to this point is the height of the cylinder, so let's call it h. Now, view this cylinder as a group of circles or play sheets that have been put on one another until it rises to a certain height. So now, how do I determine the total area that it occupies? Now we consider the area of the individual circles piled on one another until the height counts. H, as you see, represents the number of discs or circles we put on to get a particular height. So in a normal sense, the total space occupied by this figure is simply going to be the area of each circle, that is pi r squared, multiplied by the number of what? Circles we put on to get a particular height. So we can say pi r squared times h. Now, once there is a height, there is a third dimension. We learned that a circle is a two-dimensional figure, but now that there is a height, that means there is a third dimension. Thus, volume is a three-dimensional measurement. So, we now have pi r squared times h, and this we call the volume of the cylinder. So, simply put, our volume, let's say V, is simply going to be equal to pi r squared h. If you haven't forgotten your algebraic expressions you learned in year 1. Alright, let us now consider an example on the applications of this. Let's look at an example on the board. Okay, so find the volume of the cylinder of height 7 meters and this cross-section radius being, of course, 14 meters. Solution. We're able to deduce that the volume of a cylinder is simply pi r squared h. Where V is volume, R is radius, and H is the height. Pi is a natural constant, and mostly in your examinations, you're always giving that number. So in this question, we are going to consider pi to be equal to 22 over 7. Now the next thing we'll do is that we'll substitute our values into this particular formula for volume, then we solve. Okay, as you can see, the next thing we do is that we substitute the values into the expression and simplify further. Alright. And again, what you need to consider is that they gave us a set of values. So it's always good to capture them again in your solution. So we say that given V, given H to be 7 meters and R to be 14 meters, comma, it implies that our volume V is going to be equal to pi, which is 22/7, times R squared, which is 14 squared, times our height, which is 7. For now, ignore the units to make your calculations easier. Now, expanding further, you realize that 14 squared simply means 14 times 14. Then we'll bring times 7. Okay? Now, let us consider the simplification. If you consider the expression here, 7 divides 7. 7 divides 7, you get what? 1. So we can eliminate this one and that one, as you can see in the board. Now we'll be left with 22 times 14 times 14. If you are very quick with square numbers, 14 times 14 should give you 196. So we are now going to be multiplying 22 by 196. Okay. I hope you haven't forgotten how to multiply. 196 times 22. Now let's consider multiplying the 196 by 22. I hope you haven't forgotten how to multiply. 2 times 6 gives you, of course, 12. Remainder 1. Then 2 times 9 gives you 18. Plus our remainder 1 will give you 19. We'll write the 9. Leaving our remainder 1. 2 times 1 gives, 2 times 1 gives you 2. Plus the remainder 1 will give you 3. And basically you realize that we're multiplying 2 again by the whole of this. That simply means that this number here is going to repeat itself. 2 times 6, 12. Remainder 1. 2 times 9, 18. Plus 1, that's 19. 9 remainder 1. Then 2 times 2. That is also 2 remainder 1. Add it to it. That also gives us 3. Now, we add. Here we have 2, because 2 plus 0 is 2. 9 plus 2 gives you 11. Remainder 1. Add it to 3, that makes it 4. 4 plus 9 should give you 13. So 3, remainder 1. Add the 1 to the 3 here gives us 4. Thus, our volume is simply going to be equal to 4,312. Don't forget that volume is a measure of a 3-dimensional space. So the unit is going to be in meters cube. And that becomes our answer. But note that V is a variable. So it's always good to answer the question. If you leave it here as V, the examiner might assume or might decide that he or she does not understand what V is. So what you do is that you answer the question. They say find the volume of a cylinder of height. So you therefore say that therefore the volume of the cylinder is 4,312 meters cube. Take note of the unit, it's very, very, very important. That is how the volume of a cylinder is calculated. Okay, let us consider another example. Okay. Example 2. If the area of the base of a cylinder is 12 centimeters squared, find its volume if it has a height of 4 centimeters. Solution. We can recall that the volume of a cylinder is given as pi r squared h. But do you observe that pi r squared is simply the area of a circle. And remember we said that circle is simply the cross section or the base of the cylinder. So we can write our volume as V is equal to A times H, where V is volume, A is the area of the base, and H is equal to the height of the cylinder. Next step, we look at the data that was given to us. In the question, we were given the base, area of the base to be 12 centimeters. And the height to be 4 centimeters. That implies that our volume V is simply going to be equal to 12 centimeters squared times 4 centimeters. Here I can include the units because we have fewer numbers to multiply here. Now, simply we have to multiply 12 by 4. 12 times 4 gives us, yes, of course, you must have been right. That is 48 centimeters cube as our volume. We conclude the answer by saying that, therefore, the volume of the cylinder is 48 centimeters cube. I hope you went through the procedure correctly. Remember, any parts you reach and it's not clear to you, or you think the video is moving fast, just pause it and ensure that you see it clearly. And don't forget to also take very, very important notes. Okay, so in our whole discussion, we looked at how to find the volume of a cylinder. We said that you can easily visualize the formula to find the volume of a cylinder by considering the fact that a number of circular discs are being piled on one another such that a height is formed as a result. We deduce that per that scenario, the volume is simply going to be equal to the area of each disc times the height. And that was V is equal to pi r squared times H. And you know pi r squared is the area of a circle. And of course, we looked at a number of examples, and I hope that should be enough for you to keep you going. Now, let's consider another example. Now, sometimes you can be given the volume and the height, and the question will be that you find the radius of the base or the cross section. How do we look at that? This example is going to consider that. Now, let's write it down. The question says that the volume of a cylinder is 550 meters cube. If it has a height of 7 meters, find the radius of its base. Let me write the solution over here. So we know that V is equal to pi r squared h. V is volume, r is radius, and h is the height of the cylinder. And we're given the volume to be 550 meters cube and the height h to be equal to 7 meters. Comma. What does that imply, or what does that mean? What it implies is that our volume, which is 550, let's ignore the units for now, is simply going to be equal to pi, and here, once again, let's consider pi to be equal to 22 over 7. Pi to be 22 over 7 multiplied by, we know r, no, let's do the r squared there like that, times h. H was given to us as 7 meters. So we simplify algebraically. And in simplifying, 7 divides 7, so they cancel out. This will now imply that we now have we now have 550 is equal to 22 times r squared. Okay? What do we do next? We divide both sides by 22 because we're looking for r. That will be the first step to do. Eliminating the coefficient of r squared. Divide 22 and we have 1. And when you divide 550 by 22, you should come up with the number 25. The next step is that we take the square root of both sides because r squared is equal to 25. That will imply that our radius r is going to be equal to the square root of 25. What is the square root of 25? It's obviously 5. In this place, our square roots cancel out the square because they are opposite operations of one another. Now we have to conclude. And in concluding, we can say that, therefore, the radius of the base of the cylinder is equal to 5 meters. And that answers the question. I hope you are following quite well. Okay. So now, let us now look at a recap of everything we did. We were able to deduce the formula for the volume of a cylinder by considering the fact that if you pile circular discs of the same area upon each other, or upon one another, what happens? We get a height. And now the total area, the total space occupied by these discs will simply mean that we multiply the number of discs by the area of what? Each disc. Now, when you multiply the area of each disc by the number, which actually enables us to get a volume, a height for the cylinder, it simply means that we have pi r squared each, where each is for the height, and pi r squared is for the area of what? Each disc. So in conclusion, we quoted the formula volume is equal to pi r squared each. Okay, and we solved a number of examples based on that, and you realize that our formula works quite well in all the questions. I hope this lesson has been quite understandable. Let's now consider some exercises you shall be dealing with. Thank you.